Okay, we are going to look at cubic transformations. So cubic functions are just, anything cubed. So let's review what we know about this. All right, so a cubic function is x cubed. Now, I want you to take your communicator and I want you to graph for me this function, and I want you to show me 5 coordinates that are accurate. So make this a good looking graph. Hit pause, graph it, and then show me what you got when you're done. Okay. What did you choose for table of values coordinates? Did we choose maybe -2, -1, 0, 1, 2? So if you did that, then let's see, -2 cubed is -8. Don't forget when you cube that -2, you're doing -2 cubed, right? So make sure you put that in your calculator the right way if you were doing it that way. So then -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So if you graph this, you should have been over here at -2 down at -8, and then -1, 1, 0, 0, 1, 1, and then 2, 8, up here. So if you've got this, remember we said that cubic functions kind of have this S shape to them. All right, so this is what your parent function looks like. And what's the mapping notation on an original function? Just to make sure we're on the same page. Your mapping notation for this is just, it's just x, y, right? Remember, we don't put the cube on our mapping notation or anything. Okay, so this is our cubic function. It looks a whole lot like a quadratic, and we're going to kind of treat it like that. So we're going to do transformations to this thing. Now, just like a quadratic, we can put things in front of it. So we could say 2x plus 4 cubed. All right, and if we do this, then what's happening here? Our 2 is what? Our 2 is a vertical stretch. What's this 4? This 4 is going to be a horizontal translation, okay? And then your cube's telling you it's cubic. So if I want you to find the f of x notation for this and the mapping notation, hit pause, tell me what you got. Okay, so your f of x notation, remember, you're not going to show us that it's cubic in this. So you should have got, 2f of x. Now, remember, horizontal only does opposite math in mapping notation. So this is still going to be plus 4. There's nothing to factor out, so we can just write it just like that. When this becomes mapping, your 2 is vertical. It's the only vertical we've got. And then our plus 4 is going to do opposite math on the x. So we're going to end up with x minus 4, and then our 2 is going to multiply with our y. So this is what our mapping notation looks like. Okay, and on yesterday's worksheet, remember there was a problem that said transform the point 6, 1? Let's do something like that. So this is a basic of what a cubic transformation looks like. Let's take it up a notch. Let's try this. What if we have y equals -2x plus 5 cubed minus 3. Let's try that. Find for me your f of x notation and your mapping notation. Hit pause. Okay. Let's be really careful with this. I'm going to use my highlighter so I don't get myself confused. This is going to be a vertical reflection. This is going to be a vertical translation. This is going to be a horizontal stretch or compression. And this is going to be a horizontal translation. So we've got horizontal in yellow, vertical in purple. Now, before we get too far, let's go ahead and factor out this 2 from our horizontal. So if I factor that out, I have x plus, what's 5 divided by 2? 5 over 2. Don't complicate your life. Okay, so we're going to have negative f of our x. Now, you could actually write an f of x notation either way. So let's just make our life easier. 2 bracket x plus 5 halves minus 3. Remember, this has no cubic on it. Your f of x notation doesn't use the cube anywhere. We also have not done anything in opposite math yet. The opposite math only happens in mapping. So now let's go to our mapping notation. Set yourself up. Put out your x, put out your y, give yourself a lot of space. Let's go piece by piece. What about this negative? It's outside, it's vertical, it's going on the y. Okay, so there it is. Let's deal with this 2. It's horizontal, so it's going on the x, but it does opposite math, so we're going to divide by 2. Okay, let's deal with this 5 halves. Also horizontal, so it's opposite on the x. So we're going to say minus 5 over 2. And then this 3 is outside, so we're going to subtract 3 from our y. And there's your mapping notation. How do we do on that? I hope we did okay. Okay, let's try another one. I'll make this one even harder. I hope you're ready. Okay, this time I want you to transform a point. So transform, I want you to transform for me 4, 2. Okay, so this is going to be a point that's on f of x, let's say. So actually, let's back this up. Erase, erase, reverse, reverse. Where's my eraser? No, the other one. Okay. Transform for me 2, 8. Because that's actually on our cubic function. Okay, with this, y equals negative 1, nope, negative, why am I being difficult? X minus 3 cubed plus 4. All right, so I want you to transform this point. And what I mean by that is if this 2, 8 is on your original function and you've put all these transformations on it, what does this become? So you're going to need mapping notation to figure that out. Hit pause. Okay, you ready? All right, so remember, our goal is to transform this 0.28. So first, let's figure out our mapping notation. First, let's figure out what's vertical. Here's my vertical in purple. Horizontal is going to be in yellow. But in horizontal, we need to factor some stuff out first. So if I rewrite this, I'm going to have negative, negative. When you factor out that negative, now you have a plus 3, right? Careful, careful. All right, so again, vertical outside, horizontal inside. So the vertical is happening on our y. So our y is going to be negative y plus 4. And our horizontal is going to be negative x reverse minus 3. So here's my mapping notation. Now you're going to take this 2, 8 and plug it into this thing. So what 2, 8 is going to become, so 2, 8 is going to transform. Our 2 is going in here. So negative 2 minus 3 is negative 5. And here, your 8's going in for y. So negative 8 plus 4, negative 8 plus 4 is negative 4. So this is your new point that was transformed. Don't let this factoring mess you up, and don't forget to do reverse math. Okay, one more. I swear this will be the last of this kind. Okay, what if we have this? We're going for broke here. We're going all out, people. I'm going to make this as tricky as it gets. Okay, I think I've got one of everything in here. Okay, I want you to do 3 things for me. I want you to find f of x notation. I want to know the mapping notation. And I want you to transform a point. I want you to transform for me the point 1, 1. Okay, hit pause. Okay. Are we ready? Okay. Now, vertical, outside. There's all of our vertical, it's outside. Before we deal with horizontal, what do we need to do? We need to factor it out, but oh man, we need to factor out a -1/2, which is like just not nice at all. Okay, so we factor out this -1/2, that's going to leave me x. If I factor out a negative from that 1, I now have a negative. And what is 1 divided by half? 2, right? Gnarly. Okay, so your f of x notation. Okay, your f of x notation is going to be -3 f, and then you can just kind of leave this part alone. You don't really do anything here except put it inside, plus 5. All right, so there's f of x notation. Now, mapping notation. Everything inside is horizontal and happening to x, and we need to do the opposite. Except this like reflection piece. It's a little bit, you're just multiplying by negative, right? Divided by negative, multiplying by negative, same thing. So your x is going to become negative. You're dividing x by 1/2, which is the same as what? Multiplying by 2. It was subtracting x here, so we're going to add 2. All right, your y is -3, y plus 5. So here's your mapping notation. Now, what does that do to this point? So -2 times 1 is -2 plus 2 is 0. And then -3 times y is -3. -3 plus 5 is 2. So this is our new transformed point. Okay, how do we do? Are we okay with this? I hope so. All right, now let's try this with words and see how you do. What if I want you to take a cubic function? I want you to take a cubic function, and I want you to reflect it over the x-axis, and I want you to bring it down by 4, and I want it to go left by 3. Okay, hit pause. Show me what a cubic function, so you need to write the full function. Cubic function looks like with these 3 things. Hit pause. Okay, how do we do? So we've got a cubic function to start. So we're starting with this. And we're going to reflect it over the x-axis. So is that horizontal or vertical? Reflecting over x means you're flipping down. So this is going to be vertical. You're going down by 4, also vertical, and left by 3. That's going to be horizontal. So we're going to need brackets. All right, so let's come build over here. So y equals this reflecting over x means we need a negative on the outside. And then we're going to have our x, which means we need brackets. And it's going to go left by 3. So if you're moving to the left, that means we need a negative 3 cubed. And then we're going down by 4. So we're going to put this negative on the outside. So I reflected over the x-axis, and here's my negative. I move down by 4. Here's my down. Move left by 3. If you move left, oh snap, it'd be really nice if I knew my left from right. So if you're moving left 3, that means you're adding 3. Doy. Okay. I hope you all just had a minor panic attack when I did that wrong. Also, there was nothing to factor, right? Like we didn't have a reflection or a stretch inside, so we didn't need to build brackets and brackets. Okay, let's try a harder one. Maybe this time I'll know my left from right. All right, I want a cubic function. And I would like you to stretch horizontally by a factor of 2. I would like you to move right by 3. I would like you to move up 2, and I would like you to reflect vertically. All right, cubic function, so make sure you actually draw a cubic function. Hit pause. Okay, what's this look like? So, your cubic function, again, is y equals x cubed. Okay, let's discuss what's horizontal. So this is horizontal, right is horizontal, up is vertical, and then this one says reflect vertically. So we're going to need brackets. So we're going to start our function with y equals, reflecting vertically means we're going to start with a negative, and then I don't have a vertical stretch, so I'm going to go straight to my bracket, put this x in, but wait, I'm going to stretch horizontally by a factor of 2. So I'm going to do that part. And then I need to also reflect right, so I'm going to put brackets in and put that in there. So this way my 2 is already factored out, right? You could write 2x minus 6, that's fine, but don't write 2x minus 3. You need the bracket to show me that you factored this out. So now you've got double brackets, cubed, and you're going up by 2, so you end with 2. Now go back, make sure you did it all right. So stretch up by a factor of 2. Good, got it. Right by 3, got it. Up by 2, got it. Reflect vertically in the front, got it. And we're done. Okay, how do I feel about this? Not too bad? All right, so finally, I want you to do for me, let's go back to our original table of values that you had drawn. Looks like this. And I want you to transform, if this is f of x, I want you to transform to this. This was -8, -1, 0, 1, and 8. Okay, I want you to transform to this. 2 f of negative x plus 3 minus 4. Okay, hit pause. I want you to make that table values and graph it. Okay, so what did you do? Did you make your mapping notation? If you did, this 2 and this 4 were on your y, so 2y minus 4, and your x, you needed to factor out that negative, which would have left you x minus 3, so negative x plus 3 should have been your mapping notation, right? Okay, if you did that, now you're going to take these points and you're going to put them through this mapping notation. So your new points should have been careful here. Negative 2. So 2 plus 3 is 5. And negative 8 is going in for y. So negative 16 minus 4 is negative 20. And then here we've got negative 1. So negative 1 is 1 plus 3 is 4. 2 times negative 1 is negative 2 minus 4 is negative 6. 0 plus 3 is 3. 2 times 0 minus 4 is negative 4. Negative 1 plus 3 is 2. 2 times 1 is 2 minus 4 is negative 2. Negative 2 plus 3 is 1. And then, sorry, I lost my train of thought. 2 times 8 is 16 minus 4 is 12. Please tell me this is what we got. I hope so. Anyway, I'm so sorry you guys aren't there. I hope this video lesson was only a little bit bizarre and went okay. Miss Parsons is now going to give you a worksheet to try some of this on. You can get started on it now and work together, and it's going to be your work for tomorrow while you are working from home. Okay, you guys are the best. See you later.